Okay, let's talk about rational and irrational numbers. And I'm going to try to break this down as easily as possible. A rational number, notice here, you can see that the word ratio is underlined, right? The reason that's underlined is because it's any number that can be written as a ratio. And if you remember, a ratio is a fraction. So, a rational number is any number that can be written as a fraction. Okay. Now, this includes a couple of things. All integers, so any whole number, because any whole number can be written as a fraction. 1, you can make that 2 over 2 is 1, right? That's a fraction, and therefore it is a rational number. You can also do negative 3. Negative 3 divided by negative 3 will also give you a 1. So it is a ratio. Negative 6, same thing. Negative 6 over 1, or you could essentially double both. Negative 12 over 2 will also give you negative 6. So all integers are included as rational numbers. Next, all finite numbers. The word finite means that it ends. So all decimals that end. So 2.5. And again, it can be written as a fraction because 5 divided by 2 is 2.5. That is a ratio, therefore that is a rational number. Okay. Let's see what else. We've got, oh yeah, let's move on to this one. 2.25. I mean, you're not going to be able to think of a lot of these off the top of your head, but if you take 9 divided by 4, if you do that on a calculator, it will give you 2.25. That's a ratio, therefore this is a rational number. Okay? So again, all integers, all ending decimals, also all repeating decimals. Okay? So 3.33 can be written as 10 divided by 3, again, ratio, so rational number. 0.66, that one is 2 divided by 3, again, rational number because it's a ratio. And again, all you need to know, you don't need to be able to convert them into the actual fractions. All you need to know is that if the decimal repeats and keeps repeating, it is rational. Okay? And also, the other part of this that we need to know is that all perfect square roots, because it's a perfect square root. What's the square root of 4? The square root of 4 is a whole number. Again, we said a whole number is an integer, therefore any perfect square root of 25 is also rational because the square root of 25 is 5. So these are all the rules for rational numbers. Now there's only 2 different things you have to worry about for irrational numbers. 1, non-repeating infinite decimals. That means they don't repeat, but they keep going on forever. And the easy way to determine that is if a decimal changes and ends in ... that means it keeps going on forever, not changing. So if you see this right here at the end of a decimal, that makes it irrational. Okay? And that is always true. All non-perfect squares. So for example, the square root of 6 does not have a perfect whole number square root. So it is not rational, or it is irrational. And the square root of 6 is 2. Ugh, come on, pen, work. All right, 2.4449 ... because it keeps changing. Okay, same thing, square root of 17. Square root of 17, it is not a perfect square because we know what the perfect square before it is the square root of 16. Perfect square after is the square root of 25. Therefore, we know this is not going to be a perfect square, and this one is 4.122. Alright, whatever, that's 2. 3, 1, blah, 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 dot, dot, dot. Okay, and the last thing you have to worry about is there are some special numbers that you will come across in math. One of them you're very familiar with, which is pi. This is an irrational number because, again, it ends in dot, dot, dot. This is just one of the most famous irrational numbers. You will be seeing more of these special numbers when you get into later math, so advanced algebra. But for now, pi is the one you need to remember. Okay, so again, irrational ends in dot, dot, dot. Non-perfect square roots and pi. Rational, all whole numbers or integers. Decimals that end, decimals that repeat, and perfect square roots. That is the difference between rational and irrational.